Hi guys, so I've hibernated for like 10 months and then here is my first time uploading something in a while. And then so over here, since my exams are coming up, so I was thinking why not let me just show you guys what one of my papers would look like, and I specifically chose Further Mathematics paper 1. So yeah, it would look daunting to a lot of you and I would second that, but then let me just give you an overview of what my paper will look like. So again, one tip I want to say is that it will be easier compared to like the previous years because of some modifications in their testing way. So here you can see that you just need to write everything in like one single page. So we have question 1, question 2, then okay, then question 3, and then we have matrices, then polar coordinates, vectors, and then curve sketching and rational functions basically. So let me move up. And then basically what I want to do is I want to time myself. So I've put a timer here, even though exam paper suggests that I ought to like finish it in 2 hours. But I think let's try to see if we can speed run and then finish it in like 1 hour 30 minutes. So let's go ahead. Okay, so for the first question here, we see that what we need to do over here is induction. And then here we have proved by mathematical induction that 2 to the 4n power plus 31n plus 2 is divisible by 15 for all positive integers n. So for induction, we have like a fixed number of steps that we need to show. So I'm not really following my school's way, but then what I can show is I think I learned this from the textbook, but then let me kind of show it. So the first thing that I would say would be that pk be the statement that for n equals to k, because n is some variable here, so k would be our arbitrary fixed number, arbitrarily fixed natural number. So for n equals to k, this thing would hold true. So 2 to the 4k power plus 31k minus 2 is divisible by 15. And then this would be the first thing that I would write, but then this is not the first step. The first step is to verify that n equals to 1 equals to true. So we would see for n equals to 1, 2 to the 4 1 power plus 31 1 minus 2 equals to 16 plus 31 minus 2 equals to 5, which is obviously a multiple of 15. So P1 holds true. So this is the statement, remember? Okay, P1 holds true. Now for the second step, I would have to assume. So this assuming basis is a very important one because it would extend to every other number beyond 1. Because we can't just say that, oh, we need to check 1, 2, 3, 4 and so on, right? So we have to assume for any for some random number, so pk holds true. So assume pk holds true, that would mean that 2 to the 4k power plus 31k minus 2 is indeed divisible by 15. Now, the third step, and I would think that this is the most crucial step, so we want to verify that pk plus 1 is true, because if pk is true, and then the next number pk plus 1 is also true, then by induction we can prove that for all of the natural numbers this statement would hold. So for pk plus 1, what we can do here, we can say that, let me erase this because I think I've repeated something. So I want rephrase this into something like, we know that this is a multiple of 15, so let's say this is 15 times some random say z. So z is, I don't know what number, but we know that this whole thing is just a multiple of 15, and then I think, yeah, that's it. So for pk plus 1, what we have here would be 2 to the 4 k plus 1 power plus 31 to the k plus 1 power minus 2, which would be equal to 16 times 2 to the 4k plus 31 to the 31 times 31 to the k power minus 2. So we want to make from here we want to make something that resembles this. Okay, so what I could do is I could take out 15 of these, 15 times 2 to the 4k power. I could also take out 30 of these. So we can see here, these are obviously multiples of 15, and then plus the remaining one, 2 to the 4k power, plus 31k minus 2. Since we assumed that this is a multiple of 15, we could just say that the next number would be 15 times 2 to the 4k power plus 2 times 31k plus that's our previously assumed z. So we could see that if we assume pk is a multiple of 15, we can also say that this arrow would mean from here we can conclude. So pk plus 1 holds true because we assume that because here we have kind of shown that pk plus 1 is divisible by 15. So the last step would be to write some conclusion in terms of words. So since pk I kind of forgot the word already. Is it induces? I don't know. Infers pk plus 1. Therefore, Pn holds true for all positive integers, and because we only wanted the positive integers, not like -1, not like 1.5, right? So I think for this question we're done. And then use standard results from the list of formulae. I don't have that list, but then I can kind of show it. Okay, to find summation from 1 to n, 1 minus r squared in terms of n, simplifying your answer. So basically what they have in that list of formulae is that for this one, for this summation, we have r equals to 1 and then n, right? So we have, if we have 1, basically what we're doing is just adding ones n times, so from 1 to n, so we have n. So and then for r equals to 1, then until n. For r, we could have 1 plus 2, we add until n, which is equals to n times n plus 1 divided by 2. Then the next one would be r equals to 1 and r squared equals to 1 squared plus 2 squared plus n squared. So this one would be n times n plus 1 times 2n plus 1 divided by 6. Now for this one is quite an interesting exercise for you to use using induction, so I encourage you to try that. But now we have to go back to the question. So what I can do here is I can break it up. What I can do, I can just write r equals to 1 and then 1 minus r squared is equals to, the breakup, r equals to 1 and 1 minus r equals to 1 and r minus r equals to 1 and r squared, which is equals to, as I've written here, n minus n times 1, no, n times n plus 1 divided by 2, minus n times n plus 1 times 2n plus 1 divided by 6. Now, what I would do here, since we see that we have an n in all three terms, I can take the n out. And then what I want to do next would be to take out a 6. So what I'll have here would be 6. So this cancels out. Minus times 6, we have 3n plus 1 minus, can I just multiply this? So we would have 2n squared plus 3n plus 1 This is gonna take some time. Equals to n over 6 times 6 minus 3n minus 3 minus 2n squared minus 3n minus 1. What we would have left is 6 minus 3 minus 1, we have 2, and then negative 3, negative 3, negative 6, and then we have minus 2n squared. So these are, I can divide both of these by 2. So we have n over 3 negative n squared minus 3n plus 1. Sorry, it's a bit raining here. I kind of got splashed by water. But anyways, I think this is how we should do it. I think I need to check again. 6, 3n plus 1, 2n squared plus 3n plus 1. Then yeah, so this is actually what goes through the mind of your typical A-level candidate when they are sitting for an exam. Just reminding, n squared plus 3n minus 1, because you're inverting all the signs. Then okay, yeah, I think there isn't more stuff to break it down into, so I'll just leave it as such. And then for this part, I've cleared it, so I don't know if I've gotten 3 marks or not, but then we'll see in the next video. Okay, so show that 1 minus r squared, oh no, times r squared plus 2r plus 2 times r plus 1 equals to, oh my god. Show that this one, show that left hand side equals to right hand side, and then hence use the method of differences to find the whole thing. So hence means that you need to use what you've just proven above. So I could prove from the left hand side to right hand side. I could also prove from the right hand side to left hand side. So I could either go this way or either go this way. But then this time I'll pick the right to left method. So I'll just write RHS equals to r plus 1 over r plus 1 squared plus 1 minus r times r squared plus 1. This whole thing is obviously equals to r squared plus 2r plus 2. Then, so what I would have here is, okay, r squared plus 2r plus 2 times r squared plus 1, because this is the common denominator. So what we have here would be r plus 1 multiply this one, so r squared plus 1 minus r times r squared plus 2r plus 2. Now, I'm running out of space. Oh my god. Okay. R squared plus 2r plus 2, r squared plus 1. So what I get here would be r cubed plus r squared plus r plus 1 minus r cubed minus 2r squared minus 2r. So cut, we have negative r, we have negative r squared, negative r, so we would have 1 minus r squared. Then everything else follows. Okay. Hence use the method of differences to find. Method of differences is basically seeing that, oh, the next term would kind of like repeat, so we just cancel off stuff. I think I'll just write it on the right of the paper because I'm running out of space. So sorry guys. And then we have r equals to 1 and 1 minus r squared. Then this absolute mess. Then we can have r equals to 1, and then we can have r plus 1, r plus 1 squared plus 1 minus r squared plus 1. So we basically have, okay, the method of differences would be something like 1 plus 1, 1 plus 1 square plus 1, minus 1, 1 square plus 1, right? And then you plus 2 plus 1, 2 plus 1 square plus 1, minus 2, 2 square plus 1. But then what you see is this term perfectly matches up with this term. Then, of course, this term will also match up with the next term if I could write one more. So, yeah, one more. 3 plus 1, 3 plus 1 over 3 plus 1 square plus 1 minus 3 square over 3 square plus 1. You can see this term matches up with this term. So these two match, so we can cancel each other out because of the different signs. Then you just add it. So just use a bunch of dots to represent. Then for the last one, we would have n plus 1 over n plus 1 square plus 1 minus n over n square plus 1. Let me find where. N over n square plus 1. So this previous term will be cancelled out as well. So normally what we will have is we will have the smallest term and largest term remaining. So let me write it out. We would have change it back to black. N plus 1 over n square plus 2n plus 2 minus 1/2 would be equals to 2 times 2n squared plus 2n plus 2 times 2n minus 1 minus n squared minus 2n minus 2. I think that would be correct. I don't know, man. Which would be equals to, this is 2n plus 2, so I can just cut this whole thing off. Negative n squared over 2n squared plus 2n. Hey? No, wait. Negative n squared over 2n squared plus 2n plus 2. So this is what we get in the end. Okay? Now, from here, we want to deduce the value, which is only 1y. Oh my god. Okay. Deduce the value of this whole thing from 1 to infinity. So what we have here is, I think you could just think of normal value. So how would I say? As this n pushes, approaches infinity. So maybe let's put like very large numbers over here. So let's say negative 500 square over 2 500 square plus 2 500 plus 2. And then, oh, we could maybe put like say 9999. I don't know. If you want, even put 69420. Anything. So 69420 square. Okay. I think I might get banned because of this. I don't know, man. 69420 plus 2. This whole mess. So as you can see, these two terms, they have a lesser effect as the number n approaches infinity. So I could just state the value of this. I could just state the value of this because this is just only one mark. So this one, I'll just write negative 1 over 2. Because, as you can see, this and this kind of cancel out, right? And then these two, as n approaches infinity, they don't have that much of an effect. So this would be the conclusion for our question 2, I guess. How do I move it back to the left? Oh my god. I'll move it back, but it isn't letting me. So we move to question 3. Then now the equation x to the 4th power minus 2 to the x3 cubed minus 1 equals to 0 has roots alpha, beta, gamma, delta. You need to know your Greek alphabets well at this point. And find the quartic equation whose roots are alpha cube, beta cube, gamma cube, delta cube, and then state the value of alpha cube plus beta cube plus gamma cube plus delta cubed. Okay. So what we want to do is we could say, whose roots are alpha cube, beta cube, gamma cube, and delta cube. I think not really confident with this question. Would it be okay if I skip it first and then I come back later on? So, okay. I'll do question 4 first, but then, yeah, do remind me as I'll come back later on. Oh my god, I don't think I have enough time. The matrix M, the matrix M represents the sequence of two transformations in the xy plane, given by a rotation of 60 degrees anti-clockwise about the origin, followed by a one-way stretch in the x direction, scale factor d. D is not equal to 0. Find M in terms of d. Okay. So the first transformation would be a rotation of 60 degrees anti-clockwise. So let's say you have this random vector over here, because matrices could be imagined as like functions but applied to vectors, if that makes sense. So like if I say, okay, this vector I have, no. Let me draw two others actually. So this one, we would call this 1, 0, and then we call this 0, 1. So these are unit vectors along the x-axis and y-axis respectively. And then if we want to apply a rotation of 60 degrees anti-clockwise, so this is so this would be clockwise, but anti-clockwise would be this. So we could write after this, it will look something like this. Okay. So this one would be give me a second. This is still 1, but then this is 60 degrees, and then so this one would be sine 60. This one would be cos 60. So we would have the matrix would look something like for this one, because if any of you has taken A-level further math and then could remember this, our identity matrix, the one where nothing is changed, it is in the form of 1, 0, 0, 1, right? So 1, 0, 0, 1. Then I'll look in terms of vectors. So this one column represents one vector. So after rotating 60 degrees for this one, it moves here. So I would have an x coordinate of cos 60, and then I would then have a y coordinate of sine 60. Then I'd have an x coordinate for this y unit vector. I'll have a x coordinate of negative sine 60, because 60 is like this, I don't know. And then I also have a something cos 60 as the height. So these are special values, so you should kind of know them by heart as of now. So this would be our first matrix. Then this is the first transformation. And then for the next transformation, followed by one-way stretch in the x direction, scale factor d. So let's say I have something like this, right? This is originally what I have. And then this one along the y-axis, this remains unchanged, but if this were to be my unit vector, I'll stretch it along by a factor of d. So maybe let's say this is 1, 0, then later on this one will become d0. So we would have the second vector to be d0, because this is the x unit vector. And then for the y unit vector, this is unchanged, so 0, 1. And then note that this is followed by, so this would be the outer one. So if you kind of remember like something like fgx, right? Gx would be the inner one, and then this one will be the outer one, right? So what we have here would be, we know that find M in terms of D. Okay, so the first one, rotation of 60 degrees, I could just state, right? This would be cos 60, sine 60, negative sine 60, cos 60, which would be what I've written below, negative, and then 1/2. Now, and then one-way stretch in x direction. I'm abbreviating so that I don't need to waste a lot of time. So I would have d001 because this one unchanged, this one stretched by factor of d. And then what we have here is the first transformation we'll write inside. Oh my god, wait. 1/2. Then the second vector would be d001. So matrix multiplication is a little daunting, but then this is a 2x2, so it's not really that challenging. But then for the first, so our resultant, since this is a 2x2 matrix and then this is a 2x2 matrix, 2x2, our resultant matrix will also be in the form of a 2x2 matrix. Okay, so we just cut these off. Now what we have here would be, we'll have to do something in the form of d times 0 plus, no, d times half times 0 times root 3/2, something like this. And then I'll just kind of count it in my head, or should I show? I think I'll show everything. Showing everything will be better. Oh my god, this is so long. D times half plus 0 times 3/2. And then for my next one, I will have this one. So d times negative 3/2 plus 0 times half. Then I will have this one. So I'll have 0 times half plus 1 times 3/2. Finally, I will have this one. So 0 times negative 3/2 plus 1 times half. Now our resultant vector would, our resultant matrix would look something like 0, 0, yeah, d/2. Then we would also have negative d 3/2, and then we have this one 3/2, and then half. So this would be m. Okay, and then we're done. Now the unit square in the xy plane is transformed by m onto a parallelogram of area half d square units. Now show that d equals to 2. Okay, so for those of you that do not know what this implies or have zero idea about it, basically what it's saying that if I have something like this, so since a unit square is just like, okay, it's formed by 1, 0 and then 0, 1, right? Then I don't know, maybe I have some sort of random transformation over here. And then if you know about the determinant, which I think most of you, if you learn something like this, the determinant would be 1/AD minus BC. No, would be AD minus BC. This would represent the scale in area. Okay, this is also kind of like a small activity that I would also like to request all of you to kind of try out, and then maybe just do on a piece of paper or something. But then basically I will have to kind of multiply this, so I'll just write out determinant equals to could you hear lightning? I don't know. d/2 times 1/2 minus 3/2, 3/2, then negative d 3/2. So we have d/4 minus negative 3d/4, which is equals to d, right? And then this is the scale factor. This is also the scale factor. So I need to equate half d squared equals to d, and then d squared equals to 2d, d squared minus 2d equals to 0, d times d minus 2 equals to 0. Since I can't have d equals to 0, because that's implied by this part, right? So if I move down, I'll have d equals to 2, and then voila, it's solved. Okay, and this is how we do for v. Now the matrix n is such that mn equals to 1, 1/2, 1, 1/2. Find n. Okay, the thing here with multiplication is that we need to do inverse matrices. Okay, so if I know that mn equals to 1, 1, half, half, then we need to also know that matrix multiplication, the order matters. So if I put the inverse of m here in front, give me a minute. Sorry guys, rain poured into my room just now, but basically what I wanted to say is if I put an inverse of m in front, so let's say I put also an inverse of m in front, right? These two cancel off and become the identity matrix, so which basically means I can cancel off the whole thing together. Now, hence, n would become m negative 1, so inverse of m times this matrix, right? Now, I will need to find my inverse of m. But then, let's see what the inverse, what this is. Okay, so we bring down what we've got of m previously. M is equals to d squared set 3 over 2, half of d set 3 over 2, negative set 3d over 2, I don't know, doesn't really matter, and then a half, right? So this one, and then for this one, the inverse of m would look something like 1 over the determinant. So 1 over, we found that the determinant is d, right? And then for this one, the modifications that we need to do would be we reverse these two, we reverse the positions of these two, and then for these two we reverse the sign, means positive or negative, and then for these two we reverse the position, right? So we have half, then d over 2, then we have negative 3 over 2, and then we have positive 3d over 2. So this would mean that my inverse of m would be 1 over 2d, negative 3 over 2d, 3 over 2, and then 1 over 2, right? And then find n. So we know that n equals to that inverse matrix. So 1 over 2d, negative 3 over 2d, 3 over 2, and 1 over 2, multiplied by that 1 half thing. Then we do matrix multiplication as always. So we would have this kind of, 1 over 2d times 1 plus 3 over 2 times half, and then 1 over 2d times 1 plus 3 over 2 times half, and then negative 3 over 2d times 1 plus half times half. And then actually it's basically the same thing on the right, so I'll just kind of neglect it if you guys don't mind. 3 over 2, okay, 1 over 2d plus 3 over 4. Then at the right will be the same thing. And then we have negative 3 over 2d plus 1/4, and that will be the same thing. So I need some time. For this one, it would be 4d times 2 plus 3d, and then repeat the same thing, and then 4d negative 2 3 plus d, then negative 2 3 plus d over 4d. So this would be n. Okay, so this is n. Find the equations of the invariant lines through the origin of the transformation in the xy plane represented by mn. So if basically what I want, an invariant line is something such that it will pass through the origin, right? And then if your original vector was like this, and then after undergoing this transformation, it still stays on the line, so it's not like knocked off or something. It's not like this. It still stays here, but then you could just think of it as like a scalar factor. Then we call that an invariant line. And then that is something that we will have in further period 2, that we will learn something called eigenvalues, eigenvectors. So eigenvalue is the scale, eigenvector is some vector that lies on that line, precisely. And then find the equations of the invariant lines through the origin. Okay, so Mn would be... Okay, so we know that we can say y equals to mx, right? And then let's say Mn is equals to 1/2 times x multiplied by mx, because this is the coordinates can be represented in vector form because from the origin, would be equal to some scalar multiple k. So this is a scalar, and then x times mx, right? So what I want to do is, I can just write this. I will say x plus mx half x plus half mx equals to kx and then kmx. Now what I would have to equate this, so x times m plus 1 equals to kx, and so from here I could deduce that k equals to m plus 1, and then half x m plus 1 would be equals to, so m plus 1 times m times x. So I can cut these. So here what we have left is something in the form of some quadratic equation, actually. Then we have, say, m plus 1. I'll multiply both sides by 2 first, equals to 2m squared plus m, right? And then we have 2m squared plus m minus 1 equals to 0, because I moved everything to the right already. Okay, so when you've reached some certain level, I think you can do this also. Just do more math, basically. I know I might sound like bad advice to y'all, but m would be equals to, so quadratic equation substitution, 1 squared minus 4ac, sorry, 2 equals to negative 1 plus minus, this is 3 over 4, so we will have either negative 4 over 4 or 2 over 4, so just negative 1 or half, yeah. I know my working isn't like the most tidy one right now, but I'm just basically showing you how I would solve this whole thing. So we could say invariant line, so they'll look something like this. So we know that our invariant lines we could represent maybe by using L1. So L1 would be equal to y equals to negative x, since m here represents the gradient. Then our L2 would be something like y equals to half x. Okay, so case solved. Now let's go down. Okay, polar equation. Curve C has polar equation r equals to a cotangent 1 over 3 pi minus theta, where a is a positive constant and 0 theta 1 over 6 pi. Now, one important conversion that I want to show you guys here is that 1 pi, this is in radians, obviously, would be equal to 180 degrees. So what we have over here is 1 over 6 times 180 degrees, which would be 30 degrees. And then polar coordinates look like something like this. So this is our polar, our origin in your polar plane would be called the polar. And then this positive x-axis would be called theta equals to 0. And then as you go anti-clockwise, here will be theta equals to 90, something like that, right? So have polar equation 0. Okay. Now we kind of need to recall some special values over here. So originally we have cotangent 1 over 3 pi. Just think of it as cotangent 60 degrees, which is 1 over tangent 60, 1 over cert 3. And then the maximum value would be something like, okay, pi over 6, right? Yeah. So 1 over third pi minus 1 over 6 pi, which will still have 1 over 6 pi. Then cotangent 1 over 6 pi would be equals to 1 over tangent 30 degrees equals to 1 over cert 3 equals to cert 3. Now, and then this whole thing is multiplied by, like, say, some a. So it's given that the greatest distance of a point on C from the pole is 2/3. Sketch C and show that a equals to 2. Okay, so we have this thing, and then our range is still like, so this is 90 degrees. I want to cut it into 3, so this one would be our line. Theta equals to pi over 6, since this is our kind of upper limit. And then we need to start from something like 1 over cert 3a, which is around, I don't really know, is it like 0.6 something, 1 over 1.7, 0. I guess 0.6 or 59 something, I'm not really sure. And then we have cert 3, okay, so this would look something in the form of this. So this would be an equation. R equals to a cotangent 1 over 3 pi minus theta. You don't really need to draw like a very perfect picture, but then yeah, this would be something that would kind of be desired. I'm not really sure. And then it's given that the greatest distance of a point on C from the pole is 2 cert 3. So as you can see here, the greatest distance would be this one, right? So let's say R max, right, greatest distance is equals to a cotangent, since this is the largest angle that you can make over here, 1 over 3 pi minus 1 over 6 pi equals to cert 3a equals to 2 over cert 3. So from here you can deduce that here it can be deduced that a equals to 2. So this is done. And then yeah, this is how you solve part 8. Now, find the exact value of the area of the region bounded by C, the initial line and the half line theta equals to 1/6 pi. So the area that we're finding is this one, right? And then this one represents something in the form of half r squared d theta. Okay, so because you could basically imagine like a very small d theta, and over here, and then here the r is like almost the same, so it kind of resembles a circle. And then you need to add up all these. So this is where the formula came from, right? So this would be the formula that we'll be using. And then it's, again, r here is represented in the form of theta. So okay, give me a minute. We need to integrate. So what we have here, we have area equals to half. Okay, we integrate from 0 to pi over 6, because this is the lower limit, this is the upper limit. And then r squared d theta, and then half 0 pi over 6 a square, then cotangent square 1/3 pi minus theta. Okay, cotangent square 1/3 pi minus theta d theta. Let me recall. I think it's something like I think the kind of forgot my differentiation. Give me a minute. We are -1, then wait 1 minute, this does not make sense. tangent secant square, cotangent square. Okay. Yeah. So I think at this case I will need to apply the identity sine square theta equals to plus cos square theta equals to 1. Then since we're having, like, say, we need to divide everything over here by sine, I think. Yeah, sine square theta, because I'll show in a minute actually. So we have 1 plus cotangent square theta equals to C as C square theta. So, and then tangent square, cotangent square. Okay, give me a minute, let me think of something. Cosine theta, sine theta, -1. This is what would happen to you if you don't memorize your formula clearly. Yeah, so would be negative sine theta square minus cos theta square theta, and then sine. Yeah, okay. So this whole thing here, right, would be equal to, so sorry for stalling you guys time, but then you click on this video anyway. So 1/2 a squared, because a is constant. So for cotangent, I could rewrite it into C as C square cosecant square minus 1. So cosecant square, this whole thing, 1/3 pi minus theta minus 1, this whole thing, delta theta would be equals to 1/2 a square. So to integrate this, so d tangent cotangent theta equals to negative C as C square theta. Okay, so we have, I think we should be having a negative, but then anyways, so negative cotangent 1/3 pi minus theta, and then you would have to, how do I say this? You have to divide the derivative of this whole thing. So the derivative of this whole thing is -1. Okay, and then when you integrate this, we'll have minus theta, and then your upper limit pi/6, lower limit 0. Okay, so we would have 1/2 a square, cancel, cotangent 1/3 pi minus pi/6 minus pi/6. I think I need a bigger bracket. Minus cotangent 1/3 pi minus 0 minus 0. Okay. Oh my god, why am I running out of space? Okay, still space here. 1/1/2 a square. Cotangent, this is cotangent pi/6, which we've shown is cert3 minus pi/6 minus, this is 1/cert3, then plus 0, which does not really have any effect. We have, this is actually 3/cert3, then we would have 1/2 a square 2/cert3 minus pi/6 unit square. I don't really know if that's like a better way of writing this, but then yeah, this is basically for question 5b. Then moving down, show that C has Cartesian equation. Oh my god. Okay. Let's see what C is again. Okay. Let me write down again. C, R equals to A cotangent pi/3 minus theta, right? And then we have our range 0 to pi/6. Now, Just a little side note for all of you who are watching this video right now without any background knowledge on further mathematics. Basically, since r is your distance from your r is the distance from your origin to that certain point. So if I were to convert this back into your familiar x and y coordinates, then your y coordinate would be something like r sine theta. So y equals to r sine theta, and then your x coordinate is r cos theta, right? So we have r cosine theta, r sine theta. Okay. Now, show that C has Cartesian equation, blah blah blah. R equals to a cosine theta. Okay. Let me think. I don't know if I want to prove from right to left or left to right. I need a moment to ponder about this. Okay guys, so I think I would reuse the strategy of proving from right to left. So originally, conventionally, your proof would be to prove from this one to this one. But then I think if you're proving from your result in this question to what you've originally obtained, that doesn't really make a difference, I think. Okay, but anyway, since we have here that, oh yeah, oh, a equals to 2. I forgot this. So a equals to 2. Let me write something. Oh my god, 2 square times 2/3 minus pi over 6 equals to 4 over 3 minus pi 4 over 3 minus pi over 3 unit square. Yeah, so definitely look at the question one more time. Okay, so r equals to, then I think, okay, 2 cotangent this whole thing. So think, let me try proving from left to right. So r equals to 2 tangent pi over 3 minus theta equals to 2 over 10 pi over 3 minus 10 theta. 1 plus 10 pi over 3 10 theta equals to, oh my god, 2 times 1 plus 10 to 10 pi over 3 equals to 1060 degrees, which is equals to cert 3 10 theta over cert 3 minus 10 theta. Okay, so this is your r, and then recall that r sine square, I don't know, r square sine square, this is basically x square, then plus r cosine square, this is your, no, oh my god, wait, my brain's fried. Y square plus x square equals to r square. So we basically have x square plus y square equals to, no, root x square plus y square equals to 2 plus oh, okay, one more thing, sorry, one more thing I want to say over here is also that since we have x equals to r cosine theta, y equals to r sine theta, recall this, then if we want to obtain tan theta, we can obtain from r sine theta over r cosine theta, which is equals to y over x, right? So I can convert this. So 2 times 1 plus 3, what's this again? Y over x over cert 3 minus y over x. Okay, this whole thing, and then I could show, I move this whole thing up. So we will have cert 3 over y minus x times cert x squared plus y squared equals to 2 1 plus 3y over x, and then multiply both sides by x. Okay, I know. Okay, this might look like a division sign, but since that I've said that, just kind of bear in mind. Okay, we have x sub 3 minus y times root x squared plus y squared equals to 2x plus y sub 3. So let's see. 2x plus y sub 3, correct. Then x sub 3 minus y times this whole thing. Yeah, so I've proven this, so I can just write as shown, and then we can move on to the next question. And yeah. A-level further math. Guys, A-level further math. So for question 6 here, we have vectors. This is one section that you can easily slip, in the sense that if you make one wrong calculation mistake, your whole question is just gone basically. So let t be a positive constant. The line L1 passes through the point with position vector ti plus j and is parallel to the vector 2i minus j. The line L2 passes through the point with position vector j tk and is parallel to the vector negative 2j plus k. Now, for ijk, right? Ijk basically represent unit vectors in the x, y, z directions. And then for vectors, we could basically write something like, okay, let's say I'll give a random number, so negative 3i plus 4j minus 2k, right? I could convert this into negative 3, 4, negative 2, which is much easier to deal with. So let's see. For L1, my vector equation of the line would be passes through the point position vector ti plus j. So write t 1 0 because it doesn't have a k component, and it's parallel to the vector negative 2i minus j. So I can write, let's say mu, this is a scalar factor, negative 2, negative 1 0. So it basically is something in the form of like, okay, I have this vector, I have this point which I have a vector, and then parallel to this vector, right? So I can just move up here, move down here. So this is actually the more basis of this more basis thing. I don't really know. But then, okay, now that you've heard me, now L2, we have the equation R equals to passes through the point of position vector j plus dk. So we don't have an I component, 0, 1, t plus, okay, we have mu here. So let's use something else. Let's say, I don't know, sigma negative 2j plus k. So 0, negative 2, 1. Okay. It's given that the shortest distance between the lines L1 and L2 is 21. Ooh, okay. So this one, we also have a certain procedure of finding the shortest distance. Now, the shortest distance between the lines will be perpendicular to both of them, since this is in 3D. So what we will have to do here is to find some line that is perpendicular to both of them. So this one, we'll use the cross product or the vector product. And then it will be basically like something like I times j, which differs from your scalar product, or I don't know, yeah, scalar product, I times j, yeah, something like this. And then that will be also called the dot product. Now, since this one doesn't really matter because this is just some random location on that line, but how the line actually behaves, this is what it matters. So I want to find the normal vector to these two direction vectors. Okay, so for me personally, I would write something like, okay, let d1, so this is called direction vector 1 equals to that negative 2, negative 1, 0 thing, and then d2 equals to 0, negative 2, 1, right? And then I want to find the normal vector of these two. So normal vector, I think I don't have enough time to do this everything in 1.5 hours. What am I even thinking? Negative 2, 1, 0 times 0, negative 2, 1. Okay, for the calculation of this, one simpler trick is to, like, for this one, we neglect the first row. Then we see this one times this one minus this one times this one. So we have negative 1 minus negative 2 times 0 is 0. And then for the second row, we neglect this one, then 0 times 0 minus 1 times negative 2, so minus negative 2. Then for last row, we just do something like this, so negative 2 times negative 2, sorry, let me erase everything over here. This is so messy, bro. Negative 2 times negative 2, 4 minus 0, then we have something like negative 1 to 4, okay? So we know that this vector is some form of negative 1 to 4. Then we can like kind of make a scalar product of it because it's a normal vector, and I don't know if I can say if it doesn't really matter. But then yeah, normal vector. And then what we also have here is that since we are given the points, so we're given the points on, let's say this is L1, this is L2, we're given the points like these, right? So from here to here we actually have another vector. Then we wait, let me think. So I can't really explain in words everything of the formula, but then I'll just say it. It's basically something in the form of A2 minus A1. Is it? Oh my god, I forgot. Oh my god. Over D1 times D2. So this is cross product. And then we put a modulus sign outside to represent the absolute value, so that because distances cannot be negative. So, okay, we have a cross product, and then dot product over here. A2 minus A1. We have these two. Yeah, we have these two. So we'll just use these two basically. So A2 minus A1 equals to T10 minus 01T equals to T0T. Okay, now we have the absolute value of T0T, and then cross product negative 1, 2, 4, and then the absolute value, the modulus of 1 to 4 is negative 1 square plus 2 square plus 4 square. So for the cross product, if it's the first time that you've been hearing about cross product, it's basically, you see these three lines that I've drawn here, so they just multiply these three pairs. So you have cert 21 as the denominator, and then negative t plus 0, so 2 times 0 plus 4 times t, I think. Yeah, 4 times t, so 4t. So 3t over cert 21 equals to cert 21, right? So we have 3t equals to 21, t equals to 7. Woo! And yeah, that is our value basically. So t equals to 7 is the answer. Then the plane P1 contains L1 and is parallel to L2. Write down an equation of plane 1, giving you answer in the form of R equals to A plus LB plus lambda B plus mu C. Okay, R equals to A. Okay, so for plane to happen, what you can think of, okay, let's say this is our origin. Then we have some vector that points to some random point, some arbitrary point in the plane. And then for this plane, we could draw from this point in the plane, we can draw two vectors within the plane, so that no matter how many scales I could do this, I could do this, I could do this, and you know, any vector in the plane could be represented by these two vectors. Okay, and basically we have a plane equation. So the plane P1 contains L1 and is parallel to L2. Now, since we have this since we have this the position vector of this one, of this certain point, right? So the position vector of this point here in the plane would be t10, and then again it contains the entirety of L1. So we had this one, so -2, -10. So one of our direction vectors here, -2, -10, and then the other one would be parallel to the vector, okay, -2j plus k. So we have the other direction vector to be -2j plus k, so something like this, okay. And then we would have r equals to t10, right? So that would be our a, and then lambda is a scalar, b would be -2, -10, but then since if you invert it, doesn't really make a difference, so I'll just write 210 plus mu 0, -2, 1. Okay, so this would how your plane look like. This would be how a plane look like, and then yeah, this is the answer. Since this is just one mark, you just state it, and then yeah, you're done. So the plane P2 has Cartesian equation 5x minus 6y plus 7z equals to 0. Okay, so if your plane has an equation that looks like this, right? Again, random arbitrary plane. Your normal vector would be in the form of this one. So this normal vector is 5, -6, 7. And then find the acute angle between plane 1 and plane 2. Okay. Plane 1, plane 2. We knew that the direction vector, from here the direction vector of these two vectors oh my god. We know that the normal vector of these two direction vectors that I've underlined in black is what we've obtained here, right? So, okay, let me just draw some random other, oh, wait. Okay, then let's say this is the normal vector of this vector. So this angle is actually just equal to this angle because your normal vector, right, is basically perpendicular to your plane. So you're rotating everything by 90 degrees, and then the rotation of 90 degrees effectively cancels each other out. So to find the acute angle between L2 and pi 2, oh, wait. Okay, I get what's going on. So find the acute angle between L2 and pi 2. Our pi 2 has normal vector 5, -6, 7. L2 has direction vector. What's the direction vector again? 0, -2, and then 1. Yeah, 0, -2, 1. Now, I also want to write down the normal vector to pi 1, which is -1, 2, 4. So, okay. Now, for finding angles, what we do is, let's say we have two vectors, right? This is some equation that I cannot explain here in this video, but I'll just state it out. So if I have vectors A and then vectors B, I use the dot product or scalar product. It will be equal to the magnitude of A times the magnitude of B times cosine the angles between them. Okay, so I have these two. Find the acute angle between L2 and pi 2. Okay, I'll use the normal vector first. So I can say that 5, -6, 7 dot product 0, -2, 1 equals to the magnitude, which is equals to 5 square plus -6 square plus 7 square times 0 square plus -2 square plus 1 square times cosine theta, and then multiplying this, cosine theta would be equals to 5 times 0 times negative 6 times negative 2, 12 plus 7 over 25 plus 36 plus 49, 110 times cert 5. Okay, so this is 19 over cert 550, which you would absolutely need your calculator, but I don't have one. I don't have mine right now. I don't know where is it. I think I need. Give me like. Wait. Give me a few seconds. I'm going to find my calculator. Okay. So I borrowed the calculator from my friend. And basically, so I have cosine theta equals to 19 over cert 550. So give me a few seconds as I press my calculator. No, my friend's one. Cert 550. Okay, equals to 35.9 degrees. It's actually 35.888 something. Okay, but then recall that what you're doing right now is like, okay, let's say this is the line, right? This is the line, and then this is your normal vector. So what you're finding is this, but then what the question wants is between the plane. Okay, so we need this, but then what we found is this. So the acute angle, which I could maybe use alpha. Let me just point out. Okay, acute angle alpha equals to 90 degrees minus 35.9 degrees equals to 54.1 degrees. Okay, so this would be the answer to C. And then I'll just tell you guys how I type this out. Okay, so you just basically type into your calculator cosine -1. Yeah, and then wait, just get the answer from the calculator. Okay, now find the acute angle between pi 1 and pi 2. So P1, no, actually P1, I don't really know how you pronounce that, but anyway, 5, -6, 7. So you have your normal vectors of the planes, which cancels each other out. So we know that, okay, 1, oh no, wait, -1, 2, 4, dot product 5, -6, 7 equals to, -1 square plus 2 square plus 4 square times 5 square plus -6 square plus 7 square. Excuse my handwriting, it's always been this ugly, but anyways. Cosine theta, and then we have cosine theta equals to -5 minus 12 plus 28, 21, 10 equals to 16 minus 5, 11 over 2310. So over here, we could just take this angle because it's already what we wanted anyways. Theta would be, I can just write it out. You don't really need to write it out in the exam, I guess. Cosine -1, 11 over cert 2310 equals to, okay, kind of a big number, I guess. Cosine 11 divided by cert, okay, is it 11? 2310 equals to 70, no, equals to 76.76995 something degrees, equals to 76.8 degrees. Okay, so this would be your answer to this lengthy vector question. Okay, okay. Now we have the curve C has equation x squared plus x plus 9, x plus 1. Find the equations of the asymptotes of C. Now, I can kind of simplify this question a bit. Oh, I also have one question above. Oh my god. Anyways, y equals to, I could take x plus 1 out, so x plus 1 times x plus 9 over x plus 1, which is basically equals to x plus 9 over x plus 1, correct? Now, find the equations of the asymptotes of C. Now, if I let my value of x approach -1, so this whole thing approaches 0, right? Approaches 0, then my value of y would approach infinity, because it's just gonna get bigger and bigger and bigger until you can't really see where's the end. So x equals to -1 here is an asymptote. An asymptote is basically some line which you can't really touch. So let's say I'll just put a dotted line and then it gets closer, but you don't really touch it. Now, if I let my value of x if I let my value of x tend to infinity, approach infinity, then my 9 over x plus 1 would have less of an effect, so it will be 0. So from here we can deduce that y equals to x is also an asymptote. Because you can't really touch the line y equals x, the 9 over x plus 1 must always hold some value. It cannot be 0. Right? So the equations of asymptotes of C would basically be x equals to -1, and then we also have y equals to x. So these are the two. Now, find the coordinates of the stationary points on C. Stationary point, meaning that its tangent is like this. So parallel to the x-axis, so dy over dx is equals to 0. So dy over dx over here, we're going to use the quotient rule, if you know what that is. So let me bring down actually. No. We have y equals to x plus 9 over 9x plus 1 -1. Okay, since this is this would be easier to differentiate. Now, dy over dx will be equal to, when I differentiate this becomes 1 plus 9 times -1. I'm just taking the power down, and then x plus 1, -1 minus 1 again, and then I need to differentiate this. So differentiating x plus 1 actually gives us 1, which isn't really that much of an impact. So so we would have 1 minus 9 x plus 1 squared. Now, this one, since I want this thing of mine to be 0, okay, so since I want 1 minus 9 over x plus 1 squared to be 0, I would need to have 9 over x plus 1 squared equals to 1, 9 equals to x plus 1 squared, x plus 1 equals to plus minus 3, because you have two solutions. So you could either have x plus 1 equals to 3, x equals to 2, x plus 1 equals to -3, then x equals to -4. So you have the x coordinates, but then since you want the full coordinate, you also need to have a y coordinate. Now, substituting x equals to 2, y would be equal to 2 plus x equals to 2, y equals to 2 plus 9 over 2 plus 1, I think. 9 over 2 plus 1 is equals to 2 plus 3 equals to 5. So we have 2, 5. Now, the second one, x equals to -4, y equals to -4 plus 9 over -4 plus 1 equals to -4 minus 3 equals to -7. So -4, -7. These would be the two stationary points. So yeah, voila. Then we also have these two sketching C stating the coordinates of any intersections with the axes. Okay, now intersections with the axis basically means either x or y is 0. So if x equals to 0, if we have x equals to 0, since we have the equation y equals to x plus 9 over x plus 1, y would be equal to 0 plus 9 over 1 equals to 9. And then if y equals to 0, which is a more complicated case, x plus 9 over x plus 1 equals to 0, and then we have x times x plus 1, x times x plus 1 plus 9 equals to 0, x squared plus x minus 9 equals to 0, x equals to plus minus, no, negative 1 plus minus 1 square minus 4, 1, negative 9. Oh my god, this is so complicated, man. Okay, so I think, not really sure about this. I think I need to oh frick, not enough time. I think I'll substitute one of them. I mean, 1.5 hours is what I gave myself, but then x plus negative 1 plus 37 over 2, 1 plus negative 37 over 2. Okay, this would equal goes to 18 times 37 plus 1 goes to 18 over 36 goes to half. So wait, does this cancel each other out? Not really sure. 1 plus 37 over 2. I think I'll just trust my solution. I don't know, I shouldn't be wasting time doing this. X, okay, let me check again. X squared times x plus 1 plus 9 equals 0, and then this whole thing. Okay, sketch C stating the coordinates of any intersections with the axis. Okay, we have this first, since I have Microsoft OneNote, why not, you know? Then I'll be moving this, right? And then one of my asymptotes would be, this is x, this is y, this is negative 1, and then we shown earlier that this is one asymptote, so we should draw a dotted line over here, and then we should label x equals to negative 1, and then again y equals to x is also an asymptote, so we should also draw a dotted line and then make it roughly cut into half, so y equals to x. This is the second what, asymptote, yeah. And then we have x equals to 0, y equals to 9, something over here. Then x equals to negative 4, y equals to negative 7, x equals to 2, y equals to 5. So it should look something like this, right? You don't really need to draw it very beautifully because it takes a lot of time, and then you don't really have that much time in the exam anyways. So 0, 9. Then the stationary point over here, 2, 5, and then not really accurate, but anyway, take it. Negative 4, negative 7. Then if you were to touch y equals to 0, or wait, x equals to, this doesn't sound right. X times, I don't know, man. Should I, can I put this on hold first? This is negative 1. It's negative 37 divided by 2. Y equals to 0 means it'll touch the x-axis, but it doesn't seem so. I'm not really sure. Did I? X. Oh, I see. Okay. X minus 4 times 1. Yeah, you really need to. Okay, so this one doesn't have real solutions. So, okay, you need to double check. This is what can happen. I'm simulating a live exam right now. So this is what it will look like, and then state the coordinates of any intersections with the axes when x equals to 0, y equals to 9, so 0, 9. Okay, something like this. Sketch the curve with equation y equals to x. Absolute value means you're just for any values of y below 0, you have to reflect the whole thing up, right? Then find the set of values of x for which. Okay. Find the set of values of x for which. Oh my god. Okay. To sketch this, put this here. And then, oh frick man. I'll just stop it, bro. I have my asymptote here again. And then I also have this asymptote. But since I'm reflecting stuff, I'll also be inclined to draw my reflected asymptote, right? So x, y. Then originally I had my value over here. Then since this was originally here, I would want to draw it. Like this. So something like this. Then something like this. This would be how your absolute value function would look like. And find the set of values of x for which this whole thing. Okay. So for this part, I can do a bit of shifting here and there. I could say that 2 x squared plus x plus 9 over x plus 1 would be larger than 13. Then I could say x squared plus x plus 9, x plus 1 larger than 13 over 2. But then this basically means that if I were to remove this absolute value, right? So x squared plus x plus 9 over x plus 1 is either still larger than 13 over 2 or smaller than negative 13 over 2, right? Because if my absolute value even more negative number, when I reflect it, then it becomes larger. So let's find a few. This one. So I'll have two equations first, right? I'll have 9 over x plus 1 equals to 13 over 2. I'll have this equation first, right? Because I don't know, man. Should I think x squared plus x plus 9 over x plus 1 equals to 13 over 2. I'll have this equation first and then I'll cross multiply, right? So 2x squared plus 2x plus 18 equals to 13x plus 13. Then minus everything, 2x squared minus 11x plus 5 equals to 0. I don't really have insight right now, so x minus 5 minus 1 equals to 0. And then x equals to 1/2, x equals to 5. Okay, so we know that at this value, at these values, the value of, so we know that at these values, the value of y is just nice, it equals to 30 over 2. Then, okay, I'll hold this for a while. I'll proceed to the next equation first. So x squared plus x plus 9 over x plus 1 equals to negative 13 over 2. So maybe I can put the negative, put a negative above. Yeah, so 2x squared plus 2x plus 18 equals to negative 13x minus 13. And then I would have 2x squared plus 15x plus 31 equals to 0. And then this one looks complicated, so I'll just use the quadratic equation. X equals to negative 15 plus minus 15 squared minus 4 times 2 times 31 over 2. Okay, and then you can see here, if you do some calculations, we have 225 minus 248, which is negative 23, which is smaller than 0, so no real solutions exist. Sorry, I'm rushing. Okay, so we only have these two, right? So we could basically skip the originally. How did we draw this? We drew something like this, right? We could basically skip this part and then just look at this part, I think. Yeah. So if we want our values of x for which this inequality holds, we would have to have, I think I'll draw it more. Oh, I'll draw it more nicely. Okay, wait. Something like this, and then maybe somewhere here, these are the two values, so 1/2 and then 5, where this y equals to 13/2. So the parts that I want to take are these. So I could just say set of values of x satisfying inequality equals to yeah, that whole thing, right? That whole thing lying fully above 13/2, I think. What's the minimum point again? -4, -7. So yeah, not to forget that this whole part actually lies above this line, so I can just include the whole part. So the range between 1/2 and 5 is rejected, so the only parts that I want is x is smaller than half. I cannot include 1/2. X is larger than 5. Okay, larger than 5. So something like this. I don't know, if it's a set, it should look something like this, but I don't know if A-level accepts this. I'm not really sure. So these would be the values, and then yeah, this part is done. I forgot that I have one more question left. Oh my god. 4 marks, 3 marks, 2 marks. Oh, rip. Find a quartic equation whose roots are. This part I'm not really sure. And then how much is my battery? 34%. I think I can. Yeah, I think I can still handle. Whose roots are. So let y equals x cubed, right? Y equals to x cubed, because if I put a inside here, then this will be satisfied. So why not let's just let y equals to x cubed, and then x equals to y to the 1/3. Okay, so we have y 1/3 to the 4th power minus y to the 1/3 power, okay, cubed, minus y 1/3 equals to 0. And then I'll move this to the right first, because this is actually just y. So 2y equals to y 4/3 minus y 1/3 equals to y 1/3 y 4 minus y, I think so. For this part, I will have to multiply. Let me think. State the value of AQ plus yeah, my brain's fried. Can't find my friend for help. Find a quartic equation whose roots are alpha cube, beta cube, gamma cube, delta cube. Guys, this is what happens if you go into the exam hall, bro. Find a quartic equation whose roots are. This looks correct, but I think I'm missing something. I don't know what it is. Okay, wait. So y to the 4/3 power minus 2y minus y 1 over third equals to 0. And then y 1 over third, yeah, 2y equals to, I'm moving this to this side, y 1 over third, y minus 1. So y 1 over third equals to 2y, y minus 1. I think give me some time, I'll just kind of figure it out. Okay, so when you cube it, you cube this whole thing. Oh, no. You cube this whole thing, then you also cube this whole thing. So you would have y equals to 8y cubed over, then this is some random algebraic expression cubed, and then if you remember binomial series, y cubed minus 3y squared plus 3y minus 1. Then I move this up, y to the 4th power minus 3y cubed plus 3y squared minus y equals to 8y cubed. And then y4 minus 11y cubed plus 3y squared minus y equals to 0. This would be our quartic equation. And then since we've assumed this, right, find the value of a cube plus b cube plus alpha cube plus beta cube plus gamma cube plus delta cube. So basically, we have y minus alpha cube, y minus beta cube, y minus gamma cube, y minus delta cubed, right, equals to 0. These are the 4 solutions. Then we have y4 minus, okay, alpha cube plus beta cube plus gamma cube plus delta cube, y cubed plus, okay, I won't write this at the back because it's time consuming. This one, if we compare coefficients, right, comparing coefficients, negative alpha cube plus beta cube plus gamma cube plus delta cube equals to negative 11. So I'll just write summation alpha cube equals to it's 11. So this would be the answer. I think you could also write S3, because S3 means the roots raised to the 3rd power. So basically meaning the same thing. So this is one part of what they want, and then find a quartic equation. The quartic equation is this. So in the next video, I'll mark this paper. Find the value of okay, so find the value of this thing, then find the value of okay. I need some brain power and I'm running out of it. Find the value of this. Okay. So recall our last equation. So y4 minus 11y cubed plus 3y squared minus y equals to 0. And then, wait, something amiss? I do feel like something's amiss. I think I'll do C first. Find the value of A4 plus B4 plus gamma 4 plus delta 4. Okay. Again, for this equation, right? Alpha plus beta plus gamma plus delta equals to not 0, equals to 2. So we'll note this first, right? Okay. Now, remember our x4 minus 3x cubed plus 1, is it plus 1? Yeah, minus 1. Then why do I keep forgetting stuff? Oh my god. Minus 2x cubed minus 1 equals to 0. So if I write alpha 4th power minus 2 alpha cube minus 1 equals to 0, right? Then beta 4th power minus 2 beta cube minus 1 equals 0, right? I write 4 of these equations, right? I could basically say S4, which is equals to alpha to the 4th power plus beta to the 4th power plus gamma 4 plus delta 4 is equals to 2 alpha cube plus beta cube plus gamma cube plus delta cube plus 4 times 1, right? Because I'm adding 4 of these together, which is equals to 2. Then what we have above, 11 plus 4, which is equals to 26. So this is how you do C, but then I'm missing this one last part. What's this? I still have enough time in the exam for sure. It's just that for the time constraint that I gave myself, I definitely do not have enough time. Find the value of 1 over alpha cube. It doesn't make sense, right? This would be equal to, okay, for this one, alpha, beta, gamma, delta would be equals to -1. And then, let me, so if I were to expand this whole thing would be equal to, wow, alpha, beta, gamma, delta are alpha, beta, gamma, delta, okay, cubed. Then this one would be a very beautiful mess, okay, plus alpha cube, gamma cube, delta cube, plus alpha cube, beta cube, delta cube, alpha cube, beta cube, gamma cube, right? So if I divide, I get like, if I divide this over this, I'll get 1 over alpha cube, and then so on. Again, it applies to all the terms above. So for this one, if we recall this equation, right, we know that the summation of alpha cube is summation of the roots is equals to 11, and then the summation of, like, say, alpha cube, beta cube, right? There are 6 combinations in total actually, but then it's a lot to take in. It will be 3, and then summation of alpha cube, beta cube, gamma cube, something like that, would be equal to will be equal to 1, because this whole thing, how do I write it? Y minus alpha. I should write it again. Yeah, I definitely did not revise for my exam, and then I'm gonna get whacked for saying that, for even daring to say that. Yeah. Oh my god, my performance. This is a minus plus. Okay, so now we have that this whole thing here is 1. Then this is 1 cubed, right? Anyway, in the actual exam, we should be like writing this in that question, right? We should be writing it here. But then anyways, this whole thing would be equal to 1 over 1 cubed, which is equals to 1. Okay? And yeah, that's the completion of one whole further math paper. And then I think I will show you my marks in the next video. Okay? So, ciao.